Welcome back to the Chitin Corner. Thank you for sticking with us and thank you for subscribing. Now at over 100 strong, today we celebrate with this compilation video of our top 10 fungal stories. From medical mysteries to fungal fiction and the most bizarre and alien examples from the fascinating kingdom of fungi, these are the topics that brought you to the Chitin Corner.
Imagine a fugitive so elusive it tops the World Health Organization's most wanted list. Not a criminal, but a fungus. Meet Candida auris, the world's most notorious microbe. Why is the World Health Organization so concerned? The answer is as chilling as these storm clouds. But how did Candida auris burst onto the scene? 15 years ago, it was virtually unknown. Then suddenly, 5 distinct strains appeared, all at once scattered across the globe. Coincidence, or something more? Can evolution really move at lightning speed? Or is there another force at play? Mycologists everywhere were electrified. Why? Because Candida auris isn't just tough, it's nearly unstoppable, shrugging off antifungal drugs with alarming ease. Did we help create this superbug? Some blame our salty diets. After all, Candida auris thrives in salt. Did our habits give rise to this microscopic menace? Or is climate change the real culprit? This fungus can survive temperatures up to 108 degrees Fahrenheit. As the planet heats up, so does its threat. The mystery deepens. But while scientists search for answers, hospitals face a clear and present danger, an enemy already inside their walls. Before Candida auris, fungi were predictable, their weaknesses well known. Now, the rules have changed. We're witnessing evolution in real time, and the stakes have never been higher. Candida auris, enigmatic, relentless, and still on the loose. The hunt continues. So many skin conditions. Everyone has one. Could they all be linked to one fungus? Malassezia is a cryptic sort of fungus, a yeast that hides in plain sight. New research suggests Malassezia as a cause for eczema, possibly due to its preference for allergen production in the less acidic environment of patients with atopic dermatitis, or eczema. But that's not all. The yeast has long been linked to the scaly, oily patches seen in seborrheic dermatitis as well as a cause of excess dandruff, and even hyperpigmentation and hypopigmentation, a condition called tinea versicolor. One species has been linked to Crohn's disease and inflammatory bowel disease when found in the gut. Another species, a cause of folliculitis. And then, there's cancer. Through translocation of Malassezia species from the intestines into pancreatic neoplasms in pancreatic ductal adenocarcinoma. So, how does it do this and why are you just now hearing about this? One trick is by staying hidden. They can't culture it in hospital labs because it requires olive oil or other long-chain fatty acids for it to grow in culture. Unless doctors and lab scientists suspect Malassezia, they won't know to grab their favorite cooking oil and sprinkle your culture with it. And it's messy, so they're not going to add it to every culture. No oil, no growth, and therefore no ability to recognize the causative agent for these many conditions. Your skin, on the other hand, is loaded with oily stuff which causes overgrowth of Malassezia, and subsequently, these conditions.
Itchy plaques, taking over her torso. What were they? She's had ringworm before, but this was different. Her previous cases of athlete's foot or tinea pedis were restricted to the skin of her left foot and easily resolved with topical antifungal medication. But this one moved fast, so itchy, and didn't respond to the topical cream. Before her appointment day even came, it had already spread to her kids. It looked like her plaques had jumped to them. The dermatologist was concerned with the ferocity of her case and sent several samples to the mycology lab for analysis. The wait felt like an eternity as the infection continued to progress, eventually taking over the majority of skin on her body. She knew she would get through this somehow, but would never forget the feeling. When the results came back, she learned she was infected with a brand new species of ringworm fungus called Trichophyton indotineae. It was resistant to terbinafine, the usual antifungal given for skin dermatophyte fungi. What's more, she may have created the environment required for the infection, through her use of topical antifungals and corticosteroids. Another antifungal, itraconazole, cured her and her kids in a matter of weeks. Thank heavens.
If you're curious about the unknown, then mycology might just be the career for you. Let's dive into the hidden kingdom of fungi. Beneath our feet and all around us lies a hidden kingdom, a world of intricate beauty and untold secrets. This is the realm of fungi, and mycologists hold the key. Imagine uncovering new fungal species that look like they belong in a sci-fi movie. Mycologists dive deep into this fascinating world, exploring everything from mold to mushrooms. But it's not just about discovery. In medical mycology, you'll use an array of tools and your instincts to identify disease-causing fungi. It's a career that blends science with wonder and offers endless opportunities for those curious minds. So if you have a passion for microbiology, the natural world, or even the idea of exploring alien-like life forms right here on Earth, mycology might be the perfect path for you. Ready to unlock the mysteries of fungi? To learn more about careers in mycology and explore the unknown, check out our full video. I bet you never thought a fungus could be this terrifying. Rhizopus, a type of mold, can cause a flesh-eating infection called necrotizing fasciitis. Yeah, you heard that right. A fungus that eats flesh. This infection is incredibly fast-acting and can be life-threatening if not treated quickly. People with weakened immune systems, diabetes, or recent injuries are more susceptible. Under a microscope, Rhizopus looks like branching threads called hyphae, anchored by root-like structures called rhizoids. These hyphae grow rapidly, spreading through tissue faster than you can say mycology. The infection progresses at an alarming rate, sometimes within hours, destroying skin, muscle, and fascia. That's why early detection and treatment are crucial. So remember, if you're at risk and notice any unusual skin changes, don't wait. Seek medical help immediately.
Could a scenario like The Last of Us actually happen? Does such a fungus possess the ability to turn us into zombies? The TV series and game The Last of Us presents a post-apocalyptic world where a mutated cordyceps fungus infects people, transforming them into zombie-like creatures. But could this happen to people? If it happens in the animal kingdom, why not us? To answer this question, let's start with what we know. Cordyceps fungi comprise a diverse group of over 260 species of parasitic fungi that mostly infect, kill, and yes, even control insect and arthropod hosts. These are entomopathogenic fungi, or parasitic microorganisms belonging to the kingdom of fungi, that can infect and seriously disable, kill, and manipulate insects, usually ants. They directly attack the insect cuticle and penetrate the body through the exoskeleton using adhesin protein to attach and lytic enzymes to hydrolyze the cuticle. They invade the host tissue and spread through hyphae or mycelium. Some of these parasitic cordyceps fungi are generalists and can infect a variety of hosts, while others are specialists. It's these specialists, namely Ophiocordyceps unilateralis, that employ behavioral manipulation techniques that hijack the insect's central nervous system, using secondary metabolites to physically move, zombify, and relocate the host to an environment that encourages it to sporulate, spread, and reinfect. Thus far, in the real world, these have all been insect and arthropod hosts. Humans, on the other hand, have a much higher body temperature and more sophisticated immune systems that keep fungi like cordyceps away, which haven't evolved the mechanisms to parasitize us. In general, human biology is a master against fungal foes, with no fungal pandemics on record. Split-screen animated comparison showing a simple ant nervous system versus the complex human brain. The ant brain appears vulnerable to manipulation, while the human brain shows intricate neural networks that are too complex for fungal control. Scientific accuracy in depicting neurological differences. And putting superficial infections like ringworm and candidiasis aside, fungi are only really skilled at infecting immunocompromised and immunosuppressed patients, such as those with cancer or who have undergone organ transplants. It's their rarity as invaders of healthy humans that prevents any significant person-to-person transmission. But what about another, already human-adapted fungus, parasite, or bacterium? Could any organism do this to us? It's the neurology of ants and other insects that leaves them susceptible. Their nervous systems are much more basic and allow for such an adaptation among parasites. Ours, on the other hand? Well, if you're watching this video and you've watched this far, I think you're safe. Please like, comment, and subscribe for more fungal stories like this.
As a frequent swimmer, she's had swimmer's ear, but this one was different. Her ear had black patches, black discharge and flaky skin along with tinnitus, or ringing in the ear, and it was painful. What was this? She had some leftover antibiotics from her last round of swimmer's ear, but figured she should go see a doctor. A quick exam revealed the culprit. The doctor could see the heads, Aspergillus heads, in her ear canal. After a few days, the mycology lab confirmed it was indeed Aspergillus niger. This was a fungal automycosis, a less common case of swimmer's ear. So what is Aspergillus niger? Aspergillus is a notorious genus of mold in the mycology world. It is quite the opportunist. If you're going to get a mold infection, place your bets on Aspergillus. This species in particular is a master of propagation, producing black spores called conidia in mass quantities. These conidia make a black dust responsible for the black discoloration and discharge. Back to our patient. She was prescribed an antifungal ear drop and began seeing improvement in a few days. Relieved she didn't try the leftover antibiotics, which wouldn't have made a dent in the dark menace taking residence in her ear. The doctor didn't have a definitive answer for why she got a fungal ear infection, but recommended against using cotton swabs in the ear or anything that may scratch or injure the ear canal. She was also told to avoid topical steroids and antibiotics that may disrupt the normal microbiota. She decided to take the advice because
he enjoyed working in the garden, gloves free. What's the worst that could happen? He'd done this for years with no problem. A skilled and experienced gardener, he took pride in his work and knew what he was doing. Ow! That was a sharp thorn. Darn rose bush. No band-aid needed. So he toughed it out. The bleeding stopped soon, and he moved on with his business. A few weeks later, what was this? A small pink bump on this forearm. It felt weird, but he was a rough and tumble guy. The next week, several more bumps, and in a single line down his arm? Must be some kind of reaction. Several days later, they burst open and began forming ulcers. Still, being a typical guy, he ignores the obvious signs that medical intervention is required. But that weekend, he began developing respiratory symptoms. Finally, his wife, taking notice, felt that he was developing pneumonia. But what was this on his arm? After a week in the hospital, with doctors and nurses poking and prodding and x-raying and piercing veins and swabbing, the answer came. He's a severe, untreated case of rose gardener's disease, or sporotrichosis. A fungus had entered his body through the prick of a thorn. But this was not just any fungus. This was a member of an elite group of fungal villains called a dimorphic fungus. In nature, they exist as saprophytic molds feeding on dead and decaying matter. Innocent. Until they enter the human body through traumatic inoculation, where they morph into a virulent yeast form. Back in the lab, mycologists note the characteristic rosette arrangement of the spores, or conidia, which, under the microscope, sort of resemble the plants they colonize. After a robust round of intravenous antifungal medication, he was back in the garden, but this time donning protective gloves, albeit begrudgingly because
she came back to her book and noticed a tiny spiky object just lying there, almost invisible. So she grabbed her camera and snapped a close-up with her macro lens. Up close, it looked even stranger. A brown sac covered in curly appendages. What could it be? Curious, she posted the pic online and waited. Hundreds of guesses poured in. Until finally, one commenter nailed it. It was the fruiting body of a bizarre fungal mold called Chatomium. That weird sac is called a parathecium, basically a tiny fungal fortress packed with lemon-shaped spores inside. All this, hiding right on her book, and she never would have seen it without her macro lens. Sometimes the world's coolest secrets are hiding in plain sight, just waiting for you to zoom in. If you loved this strange discovery, follow for more jaw-dropping fungal stories.
If you suffer from skin patches that are dry and itchy or thick and discolored nails, it may be due to birds on a wire. Yes, actual birds sitting on a wire are brave and cute, but birds on a wire is also a common pattern seen under the microscope from molds that cause ringworm and nail infections, or onychomycosis. These are fungi that irritate dead keratinized tissue such as the outer layer of skin, without invading living tissue. The most common is called trichophyton. Each colony houses thousands of tiny microconidia or tiny spores commonly called birds on a wire. Mycologists look for these to help providers diagnose patients. These amazing fungi make two types of spores. The other type are called macroconidia. The macroconidia are shaped like pencils and act as the conformation.
Thank you so much for watching to the end of our countdown, but there is no end to mycology. Keep exploring with us and on your own. Let us know in the comments which was your favorite or what topics you would like covered. Thank you. Please like, comment and subscribe for more.